Hello everyone, this is the Phoenix Group and I am Ashish Pani and my roll number is 21ME10076 and my section is 15.
My name is Ajay Paliwal and my roll number is 21NA30002 and I am from section 15.
Hello, this is Shantan Sarkar. I am from section 15 and my roll number is 21ME10073.
I am Harshada Vinay Anavkar. My roll number is 21ME10035 and I am from section 15.
Here I am going to explain you the functions of the different parts that we have used to build up this part. So here the red colored main framework is the mini chassis which I have mentioned, and here you can see there is an ultrasonic sensor which I have fitted in the front, which records the distance between the board front layout and the obstacle in front of it. So here is the breadboard and here is the Arduino UNO microcontroller, Arduino UNO R3 microcontroller board upon the robot. Now here we have used a battery. You can see this is the 9-volt battery for powering the motors, and here are the two wheels for its movement, and here are the two DC motors that are rotating the wheels on information received from the motor driver. So what is the motor driver? Motor driver is the L293D integrated circuit which we have fitted in the breadboard. You might see it in the circuit diagram. So and here we have used a caster wheel. This is a caster wheel which is used for the smooth cornering of the robot by sliding on the ground. So this is used for this purpose. Now this ultrasonic sensor, or sometimes called the sonar, has two circles in front. One is for sending the sound signal or the sound wave towards the obstacle, and one echo receiver is for receiving the echo, and it measures the duration taken for the sound to reflect back from the obstacle, and by it can measure the distance, and thus we can get the coordinates by certain equations. So we have fitted to the breadboard. Here is the L293D IC, and what the Arduino does is it can provide a maximum voltage of 5 volts. So it is used for powering the sensors, because sensors takes less voltage. So our sensors and ultrasonic sensors are powered by the Arduino, and also it is used for enabling the pins of the L293D IC. So the Arduino is used for that purpose only. And 9 volt is used for driving the motors, because motors require a high voltage supply. Now this is a UNO cable, USB cable, which is attached to the laptop from the Arduino for providing voltage to the Arduino. So this infrared sensor has two lights at the top. One always glows when power is fed into it, which is an indicator to show that power is fed into the sensor, and another light gives us the information of how responsive it is to the surface, which helps us to tune it according to our requirements. Here is the white transparent LED and here is the black LED. Now the IR ray is emitted from this white LED into the surface below it, and then it is reflected back towards this black LED. And if the black LED receives the ray reflected back, then it is a white surface, obviously, because white surfaces are good reflectors. But if it doesn't receives any reflected ray, then it is a black surface, obviously. And here is a potentiometer we can see in the IR sensor, which you can tune if your sensor is not responsive towards any surface. Now comes the actual working of the robot. So what we have done is, when the IR sensor is sensing black surface on both the sensors, because we are using two IR sensors here, we have written the code in such a way that when there will be black surfaces on for both the sensors, there will be an equal RPM in both the wheels in the same direction, such that the robot will move in the straight direction. Now if one of the IR sensors has sensed a black surface, then what we will do is rotate one wheel in the opposite direction and rotate another wheel in its opposite direction, so that the robot has a turning effect. There is a torque acting and the robot turns and the corner is forward. So we can regulate the speed of the wheels by using PWM pins in the Arduino board, by which if we tune the duty cycle of the PWM wave, the pulse width modulated wave, then we can regulate at which situation what RPM of the wheels do we want. So I have set it around some value, and for cornering I have set it to little high RPM, so that it has a fast corner and doesn't have any problem while sensing the corners and recording the distances from the ultrasonic sensor. So there will be less problem if we tune the DC motor in such a way. Here I have written the command ROS run print underscore pause. Print underscore pause is the name of my package. Inside it I have sub swan.py, which is the Python file. Here I have the port which is AC M0 port, and the port rate is 57600, which is written here. It's written right here, 57600. Here, as I am executing the command, the values are being printed of the abscissa and the ordinate till it completes its journey.